What's going on, Algebra 1? How are we doing? It's week 2 of our Google Classroom adventure. I can't believe it already. But your notes for this week are slightly different than last week, okay? This video is going to be all about quadratics and specifically words or lines that are called parabolas, more so curves. They're not parabolas, I promise. It's parabola. So let's get to the notes. Transition.
All right, algebra. I just want to preface this is going to be a lot of information. So I fully expect you to watch this video more than once because there's going to be a lot of information that you need to try to digest in order to help understand. But remember, this is our first go around at quadratic functions. This is our first go around at quadratics ever. First time you ever being introduced to it. So there's naturally going to be some questions. So let's jump right into it. Quadratic functions. Well, the name comes because of quad, meaning that the variable gets squared, like x squared. So we know that any function is going to be a quadratic if it has an x squared in it, anywhere. Okay? So quad coming from a square because the variable gets squared. Now, it's super important that we remember the standard form for a quadratic. It is always going to be a variation of this. Ax squared plus bx plus c equals 0. Where a, b, and c are known values, a cannot be 0. And x is just a variable or unknown, something that we don't know yet. Okay? Super important that we remember ax squared plus bx plus c. That is our standard form for a quadratic. It's our standard form of a quadratic equation. But something else that we need to know, parent functions. You cannot read that. Here we go. Parent functions, let's do that. It is the simplest form of a function. So the parent function of a quadratic is f of x is x squared. That's our parent function. Nothing is being done to it. It's just what it is. So, back to some fun words here. The graph of a quadratic curve is always called a parabola. I want you to say this at home with me. Parabola. It's not parabola, I promise you. It is parabola. Okay? And they look something like this. Okay? This is in fact our parent function. This is f of x equals x squared when it's graphed. You can see how it has this nice kind of U or V looking shape, okay? But it's really important that we see that there is this kind of U-ish looking behavior happening here, okay? This is what all of our quadratic equations are going to look like to a certain degree without any changes, okay? So, the next part about quadratics gets very informational and detail oriented. Okay, this standard form of a quadratic for ax squared plus bx plus c gives you a lot of information. So let's go down here. A quadratic function. Well, we know that the parent function is f of x equals x squared, and the standard form is ax plus bx, or ax squared plus bx plus c. We know it is a parabola. Now, the axis of symmetry. We all know what it means for to be symmetry or symmetrical. Okay, it just means it's going to be the same thing on both sides, kind of like we see with butterflies. But we can see that each parabola has an axis of symmetry at some place. Okay, and we can find out where this exact axis of symmetry is from our quadratic standard form equation. We can see that it's going to be whatever our b is over whatever our 2 times our a value. So negative b over 2a. So it's going to be negative whatever our b value is over 2 times our a value. We know that our y-intercept is going to be 0, comma, whatever our c value is. And then last, and certainly not least with this, we know that our vertex is first off going to be part of our axis of symmetry. Okay, that's where that comes from right there. And then we also know this F of our axis of symmetry, whatever this is right here, this is just saying the value of that number in the function. Let me move this because you are not going to see this. Of the number, of that number in the function. Okay, so if I were you, I would write all of this down. And if you need to go back and pause the video, definitely do that. It might be helpful for you to download the video and then pause it, whatever you have to do. But this right here is super duper important. Okay, this is going to make your life a whole lot easier because we would have gone very far down deep into what is the axis of symmetry, how can we find the vertex, what are the maximums and minimums, everything's like that. Okay, but speaking of maximum and minimums, you don't know those yet. So let's find out what they mean. Time for some heavy vocab. Okay, so the point through which the parabola turns direction is called a vertex. So what it means by when it turns direction, as in it's going down, going down, going down, and then suddenly it flips back up. Right here, let me change the color. Right here is our vertex. Okay, the vertex appears at 0, 0 for a parent function. When the vertex is at its lowest point on a graph, so let me give you a graph here. Why don't we go with green? Right here's my parabola. Okay, and I'm going to draw another one too. When the vertex is at its lowest point on the graph, that is a minimum. When it's at its highest point on the graph, that is a maximum. Okay? A vertical line that passes through the vertex and divides the parabola into two symmetrical halves is called the axis of symmetry. And we kind of saw that before, but I'll draw those right here just to help everybody out. Okay? So those are the important vocabulary pieces that we need to know so far. So again, if you need to pause and write this stuff down for notes, definitely do that because we're getting a lot of information here for the first time. Now, when it comes to transformations, transformations are just essentially how we change the function, how we move it around on the graph. So there's different kinds of transformations of quadratic functions, and these are generally just transformations that you will see in any sort of graphing situation. There are translations, reflections, and dilations. Okay? A translation is essentially just moving it up or down or left or right. It's sliding it up or down, okay? A horizontal or vertical. Up, down, left, right, whatever it is. I know that it's going to be a vertical translation, essentially, if I am adding or subtracting something. Adding or subtracting. I can also see that this is going to be my C. If my C value is a number, that means that my y-intercept where it crosses the y-axis is going to move, okay? I also know it's going to be a horizontal translation if my x squared term has something added or subtracted within parentheses that's being squared, okay? H units right if h is positive, or h units left is h is negative, okay? We'll talk more about what h means in another video. It's a different kind of way to write these equations. Okay. Reflections. Reflections are essentially just flipping it. When you look into a mirror, it reflects what it's seeing. Okay. So a reflection flips the graph. And it's pretty easy for us to do reflections for quadratic functions because the only difference is if it's positive or negative. And you can't really see that. Okay. But in this red one, it's really negative x squared, which is why it goes down instead of up, okay? And then dilations, as in it stretches out wider. That only happens, it either gets bigger or smaller by whatever number is being multiplied, by whatever our A value is. The graph is stretched if our A value is greater than 1, as in if the absolute value of A, so it could be like -5. The absolute value of -5 is still 5. So our graph is going to be stretched, but it's also going to be down, okay? And the graph is compressed, as in squished together, if it's a number between 0 and 1. Again, a lot of information here, okay? But this is just your intro into quadratic functions, and these are all things that we would have talked about in class. Also, part of this assignment is to write any questions that you have down in the comments below. So if you have a question so far, type it down there and you're done. It's great, okay? So let's get into what we're trying to accomplish this week. Solving quadratics by square rooting. And I have some steps for you here. This method only works when the square term can be isolated on one side of the equation and the constant term is on the other side of the equation. So my first step is I'm going to isolate the square term on one side of the equation. Isolate as in I'm going to get it by itself, what we've been doing this whole time. The second part is I'm going to square root each side of the equations. And make sure to include this plus minus right here, because any number that gets square rooted, its answer is both positive and or negative. So let me write that down here. Square rooting a number gives you an answer, or gives you a number. And I'm sorry, this isn't the best handwriting. I'm trying with a stencil today, but we'll just see what happens. So square rooting a number gives you an answer that is both positive and or negative. Again, it's not the best handwriting. If you have questions about my handwriting, that could just be your question from the video. Okay, so that's really important to note. And then my third step is isolate x to solve. Okay, so let's put this into some practice with a couple practice problems, and then we are done. Okay, again, this is what you're doing this week, is solving quadratic equations by the square root method. So first example, what are the solutions to each of the equations? We're going to start off with A. So I have x squared minus 9 equals 40. So what I'm going to do is first I'm going to isolate x, or x squared. So I'm going to add 9 to both sides. So I get x squared equals 49. And now I'm going to square root both sides. So I get x equals plus or minus 7. And that is going to be my answer for that first one. B, gotta add some stuff on here first. So, gonna draw a line. First thing I need to do is I need to add 5 to both sides. So I get 3x squared equals 12. Then I'm going to divide both sides by 3, and I get x squared equals 4. Now I have to square root both sides, and I get x equals plus or minus 2. Okay, last one here. So I'm going to draw a line down the middle here to separate both sides, to really just show that they're two separate sides. I need to get x squared by itself, which means I need to subtract both sides by 10. So I get 4x squared equals 36. Now, in order to get x squared by itself, I need to divide by 4. And I get x squared equals 9. Take the square root of both sides, and I get x equals plus or minus 3. Let me just make it clear that's a 3. And that's it. That's how we can go about solving quadratics by square rooting them. Now, obviously not everyone is going to be nice and easy like this. or nice and clean cut as this one is. If you do need to use a calculator, go ahead and jump on Desmos. Use their scientific calculator. You can also square root on your phone's calculator, okay? Um, if it comes out to be a decimal, I would suggest her rounding to the nearest hundredths place, as in the second place after the decimal, okay? And do not forget that your answer is going to be positive or negative. So, that is all the notes that I have. So again, your assignment for this video is I want you to write down one question that you have from this video, or I want you to write that things have been cleared up because of this video. But I imagine that I'm going to have several great questions because this is brand new for everybody. So, you know how to reach me. You know what you need to do. Go ahead and get started, and I hope that you have a